So for me, it's relatively new type of research because it's very short run compared to what I've been doing so far. And I think it's like a new approach and not that much share so far within environmental economists. I mean, it's more macro people that have started that. And I think it's important that we join because sometimes, I mean, I think we can improve on their assumption regarding the environment. So this paper is about carbon taxes and tariffs, financial frictions, and international spillovers. It's joint work with Stefano Caratini, Gizon King, and Givi Metzgal. So, yeah. The main starting idea is that climate risks are one very important concern for central banks. So as you know, they run stress tests regarding climate risk. And what is behind this stress test mainly, it's the fact that financial intermediaries are exposed to carbon-intensive sectors. Okay, so banks basically are lending to brown firms. And then if there is environmental policy, something is going to happen to these brown firms, then to these financial intermediaries, then to the rest of the world. Okay, so that's basically the idea. On the top of that, you also have directly, even not through financial intermediaries, a risk of recession when you put a constraint like a carbon tax, for instance, on countries. So there is some literature already studying that, so using dynamic stochastic general equilibrium models with environment, so this EDSGE, but so far it has been in closed economies. Okay, and so you can find some of my co-authors doing that. But the point is that financial intermediaries, they do operate globally. So there is a lot of cross-border lending, and there is also, I mean, trade is important for the transmission of the shocks as well. On the top of that, climate policy, we know they have an international dimension. So I just took this one from a recent paper of Lionel Fontanier and Kathleen Schubert, and here you have the 5 most and 5 least emitting industries, and what you see is that here, clearly, when you have relatively low CO2 intensity, this is where you have also very low, I mean, relatively low trade openness, okay? And so you have this positive relationship between emission and trade openness. Okay, so what we do in this paper, we study what is happening when you implement climate policy and how it does affect the economy, and we have a special focus on the role of financial friction and how you have transmission across the borders of this effect. And once we've said that, we say, okay, what is macroprudential regulation able to do to try to mitigate this type of risk? So the type of macroprudential regulation we're going to see is that you penalize the lending to brown firms compared to the lending to green firms. So what is really interesting in the EDSGE model is that you can really say something on the transition. So you can put frictions. So here we especially put an emphasis on financial friction, but we also have, in fact, adjustment cost for capital. And you could put in that adjustment cost for labor, okay? And you know that during the transition, the type of labor you need is different when you need to do an electric vehicle compared to a thermal one, for instance, okay? So these sort of things, you can account for that in this type of model. So this is why, I mean, I really think we should develop this more. So in this model in particular, you have polluting and non-polluting sectors. You have financial and trade relationships between countries, and you have these banks subject to financial friction. So we have an agency story, but at the end of the day, the idea is that you have credit supply constraint on banks. We do have climate policy scenarios. So how is exactly climate inside this model? So you can find some EDSGE models in which you have damages appearing, and I can discuss that later with you. I don't think right now we really know very well how to do that in EDSGE model. This is related to the dynamics of climate and also on the valuation of damage, exactly, because these are quantitative models. So what we do here on the backs, in some way, we have a target and we have a carbon budget, okay? And this is not in the model, we don't need that, okay? It's a decentralized one, so we just have it somewhere, but that's the rationale to have a climate policy. So we have unilateral carbon tax in the domestic economy. Then we add carbon border adjustment, and we can also have a global one. If I have time, I will show you the global one, but the story is not very different, so that's not that interesting. And on the top of that, we see whether we can mitigate the short-run adverse effect using macroprudential taxes and subsidies. Okay, this is the literature, but I'm going to skip that. So what is the overview of the model? Quite simple. We have two countries, home and foreign. We have a household, so they consume, they save, and they supply labor. We have financial intermediaries, so they collect the deposits from the households, and they lend to home and foreign non-financial firms. And these non-financial firms, they can be brown or green, and they can be for tradable and non-tradable goods. Okay, so basically we have 4 goods. They can be green tradable, green non-tradable, and so on. Okay. And we eventually have a government, and the government is implementing policy. So very quickly, I don't have so many equations, but maybe we need to have this in mind for some of the effects later on. So this is the households, okay, and consumption here. This is a CES between brown and green, okay, and then we have here a CES between home brown green and foreign brown green, okay. So here, this is where we have a CES, so we have Armington elasticities, okay, deciding whether, how to choose between home-produced and foreign-produced goods, okay, and that's basically it. What is then interesting, so they maximize utility, and this is a budget constraint, so they buy the goods, they have deposits, they get wage, they get returns on the deposit, this is dividends from banks, profits from the non-financial firms, this is transfer from the government, and here from the carbon tax, and also from the carbon border adjustment, okay? And the carbon border adjustment here is something that comes on the top of the price of the foreign brown goods, okay? So when you import foreign brown, you have to pay an additional tax that is going to be the CBAM, okay? I shall come back to that later. Non-financial firms, perfectly competitive, Cobb Douglas technology. You have emissions that are a byproduct of brown production, but you can use an abatement technology. And these firms, they have to get money from the bank to finance their capital, okay? So they use loans coming from the bank. And then they decide about capital labor abatement to maximize profit, and they are subject to a carbon tax depending on the level of their emissions. Banks. So they are using the deposits of people, that's D, and their net worth, that's N, in order to lend money to brown and green and home and foreign non-financial firms. Okay, and so you have foreign firms lending to basically everybody because they are global, and foreign banks lending to everybody because they are global, and home banks lending to everybody because they are global, okay? Okay, so this is their net worth, but nothing very interesting because that's just the return on every asset they lend, net of the deposits they have to pay for. And then this is the agency problem. This is where we have the financial friction. So we say that bank may divert a fraction of the asset. So you have an incentive compatibility constraint that turns out to be exactly, this equation that is just a constraint on how much they can lend, okay? So this is a net worth, this is shadow value of net worth, this is this fraction of asset, and this is how much they can lend. So what you just have to keep in mind is that they are constrained on their lending depending on their net worth. So what is happening through that? You have an amplification of the shocks, because when things go bad, their net worth is going down, they can lend less, okay, and that's bad for all the firms, okay? So this is how it amplifies in the shocks. So that's basically the model. Then we go for calibration. So what we do, we calibrate, so we have two countries. We choose so far United States and European Union. We have India and China not too far in our minds for next work. So that's we consider to be the main calibration, United States and European Union. We use standard international RBC parameters. I shall come back to that later because Hamilton elasticity are a bit sensitive, let's say. We also have to calibrate the financial sector of parameters. So we target banks leverage ratio in order to go back to value of parameters, sectoral and cross-border exposure, and credit spread. Okay, so we use data on all that in order to get parameters for our model. And the environmental parameters, they are defined in order to match sectoral emission intensity in the data. Okay, so far, I mean, I'm happy to have clarification question on the way if needed. So let's go for the results. So first, we start only with a carbon tax. So the way we put it in the model, that's an unexpected introduction of an $80 per ton tax on CO2 in the home country only. So, I mean, we choose this one. You can play with the model with another one. That's not going to make a huge difference. It's sort of in line with some recommendation. It's, I mean, to my idea, a little bit low, so let's consider it as a lower bound. We start with a steady state, and in period 5, we implement this tax, okay? And that's a tax you have forever. So first, we have it without financial friction, and then we add the financial friction to see how we change the picture. So nothing very surprising, so that's just carbon tax, no financial friction. So that's very intuitive. This is what is happening with brown output at home. Okay, so at period 5, it just falls. And then go on falling, you have adjustment cost. You have adjustment cost, so it takes time. And for the rest, you have, so green output, you have some substitution appearing. So green output is increasing. Brown output foreign is increasing too, and green output foreign is increasing too. Okay, so basically you reduce brown home, that is a product that is taxed. All the rest is increasing, okay? And this is exactly where you have leakage, okay? Because brown output is increasing as a result of your carbon tax at home. So we have leakage. What is happening if we have financial friction on the top? Things get worse, okay? And that's not really a surprise. So financial friction are the blue lines. What is happening when you implement the carbon tax? It's bad for the home-grown firms. And the banks, all the banks, they actually are lending to these type of firms. So their net worth is going down. So they don't have that many money to lend. They lend less to everybody. And this is exactly what we show here. They lend less to everybody, so there is a problem of capital in all the sectors, okay? And this is a slightly different because this is the one that is directly affected in addition by the carbon tax, okay? So far, financial friction, global recession, basically. So this is summarized here. Without financial friction, the capital flows everywhere else. When you have financial friction, then you have this short-run recession everywhere, and yeah, you still have, of course, even if it's I mean, in the short run mitigated, you still have some leakage appearing. Okay, brown output is increasing above the steady state quite soon. Okay, let's add the carbon border adjustment mechanism. So recall, it's just appearing here in the model in the budget constraint of the household, okay? And of course, maybe I should have put that in blue too. You have the proceed of this CBAM that is also appearing here. It's given back to the home households. By the way, we don't have export rebate. This is in line with what is currently happening in Europe. I think in any case, it's not consistent with the WTO and GATT requirements, so I'm not expecting that it's going to change soon. Okay, these are the results. when we add CBAM. So when you add CBAM, this is a pink dashed line. Basically, everything gets worse, okay, with CBAM, which is sort of what we were looking for brown output, okay, and you stay below 0, so below the initial steady state a longer time, so you can say, okay, you're mitigating more the leakage than without the CBAM. That's fine, that's the ultimate aim of CBAM. But what is happening? So CBAM is directly hurting the brown foreign firms. So in this case, now banks, they have issues with the net worth through the brown home firms and also through the foreign brown firms. So this is why it's getting worse with CBAM everywhere. Okay, and not surprising. And also you have, I mean, less leakage, or not as soon with CBAM. So that's the first thing. But then, okay, and we are transparent, but in the paper when we explain it, but you can see here, I mean, at some point it's crossing. Meaning at some point in the long run with CBAM, you actually have more leakage. This is what it means, okay? At some point you have more brown output foreign here with CBAM compared with without CBAM, okay? So here is the explanation. So first, yeah, what I just said, CBAM reduced leakage, banks are affected negatively in addition through the returns on foreign dirty capital, and they cut back supply on credit to home firms as well. So home firms here also are negatively affected by CBAM. Okay, so now what do we have? This sort of counterintuitive, surprising effect on the long run effect of CBAM. Well, this is where the Armington elasticity is the sensitive parameter. I mean, probably not the only one because we have many others, but this one plays a role. We do choose a small elasticity. I will come back to that, I mean, to the reason why we have that later. If we have a very small Armington elasticity, it means that we have few substitution out of the domestic consumption of foreign grown goods. Okay, so we have the CBAM. We don't change that much. Okay, so this is slightly reducing leakage as a direct effect, but not that much. But then since we don't change that much, we pay a lot of tax. Okay, because we don't change that consumption a lot, and it is tax. So we pay a lot of tax, meaning we have a lot of proceeds. So we have a huge wealth effect, let's say, that is favoring all goods, including the foreign grown one. So we check that. And indeed, if you change the value of this elasticity, if it becomes big instead of being small, at some point it reverses the result. Okay, so we don't have this strange long-term result that CBAM is actually increasing leakage. Okay, so then, now maybe I stay here and I explain a little bit why we choose a low one. So this is based on some recent literature. So the paper of Corsetti 2008 in Risted explained that if you want to solve a puzzle that is when you have the relationship, in fact, between relative consumption and real exchange rate, what you obtain is that model that tells you that you have a lot of risk sharing and you don't observe it in the data. So if in your model you put a low Armington elasticity of substitution, actually it reduces the risk sharing and you can reproduce the data. Okay, and so based on this goal to reproduce a stylized fact, then there is a lot of literature with low Armington elasticity, but I mean, I'm not a trade person, and I could also find values that were larger than that. So, I mean, it's sort of open. That's an open debate with my co-author as well. What we really, I mean, what we favor, and shall we keep this counterintuitive result? But by the way, that is also interesting to see this sensitivity to the elasticity or not. Okay. Last part. So can we mitigate, because I let you with this very bad picture, okay? We basically do climate policy, everything is going wrong in the short run. So can we do something to mitigate that? So what we suggest is this type of macroprudential policy. So it looks like here we have subsidy and tax on green loans. Okay, one is positive, one is negative, in order to reduce the bank's exposure to brown assets. Okay, so this is the way it is put in the model. This is why I wanted to show you the equation, but it's exactly, it plays the same role as if you have a quantitative requirement on having brown and green, okay? So on the proportion of brown compared to green that is held by the banks. And then again, we do the same policy scenario as we had before, carbon tax, and we had this home macroprudential. And what we do this home macroprudential first only at home, okay? So we have a country that decide, okay, I'm going to do a carbon tax. I know there is a recession partially going through financial institution, so I'm going to do macro-pro, okay? And then the other exercise we do is that we have a carbon tax at home, also macro-pro, but then the foreign countries is thinking, okay, oh, my neighbor is doing some climate policy, maybe I should do macro-pro, okay? And I will show you the results. So this is home carbon tax with home macro-pro, and what will you see? Well, it really reaches the goal. So in blue, you have no macro-pro, and the small black dots, it is when you have, in addition, the home macroprudential, and no surprise, it is mitigating the effect, okay? So what is happening? Maybe I'll show you what is happening abroad, and I explain that. So what is happening for the bank net worth here, it's the reverse. So that's not surprising. Home banks, they are sort of forbidden to have too many bonds, non-financial firms in their portfolio. Okay, so when there is a shock, they are not hit that much because they did not have that many bonds. But then, because the home banks, they did not want to fund the broad non-financial firms, they were funded by the foreign banks. So the foreign banks get a larger exposure to these brown firms, and this is why when there is a carbon tax, they are hit more. And so with no surprise, regarding capital, what you have is that it's favoring green capital at home, and for foreigners, it's decreasing. So what we have is that indeed, if we do macro-pro policy, it mitigates the transition risk at home, but we have negative spillover on the foreign countries because then the foreign banks, they hold a larger share of the brown assets. This is why other foreign countries, a foreign country even not doing any climate policy may think, okay, I should do macro-pro. So this is what is happening when both countries do macro-pro and only home is doing carbon tax. What you see is that indeed it's mitigating the risk everywhere, and it's better for the capital everywhere, okay? Because now all the banks, they have less brown asset initially. So when you have the shock through the carbon tax, it is not as large, this negative shock, as previously. So that's relatively interesting, because even a country that is not doing climate policy, I mean, through a carbon tax, can do a type of climate policy by having this macroprudential financial policy that says to the bank, you should not hold too many brown assets. And that would be better for the transition. Okay, how am I with the time? Just to know, because I'm sort of done, but
7 minutes to go.
Including questions? Okay, so I'm going to conclude. And I can show you, or you can find that in the paper for the global tax, but nothing, I mean, same mechanisms. Basically, you could guess it by yourself. So as a conclusion, we have shown that the financial leakage are an important story to understand what is happening in the short run when you do climate policy. We also get some type of non-standard effect of CBAM, in particular in the long run. We obtain that macroprudential policy, they are effective to mitigate this transition risk. Okay, and we show that that's true if we do carbon tax and CBAM, and if we do global carbon tax too. I did not show that, but that's the same mechanism. And we are just thinking on what would be the optimal macroprudential policies, but that's a slippery slope because we don't really have optimality there. And this is exactly what we wanted to avoid, not to have damage and everything. So that's not going to be optimal. That could be what is the best in the short run for GDP, or, I mean, but that optimal is probably not the correct word. So thank you very much for your attention.